As you progress through your mathematics studies, try to develop a sense of independence when it comes to your learning. Be prepared to choose your own path towards success. Understand that if you're aiming high, if you're ambitious and you really want to learn, then you are, in many, many cases, going to be on your own in pursuit of your ambitions. And to achieve the level of success that you want, you will probably have to go against the grain. What do I mean? I mean that the typical classroom-based mathematics course here in the UK is not, I repeat, not designed to cater for those individuals who are high achievers and who really want to learn about mathematics. It's aimed at the centre-of-the-road, disinterested, average Joe mathematics student. The aim is to get as many passes in the class as possible, even if those passes are only scrape passes. The typical classroom mathematics lesson does not aim for understanding. Why? Because learning to understand is messy, it takes time, and it's difficult to measure. What's easier to measure, what can be bullet pointed, and what gives the superficial appearance of taking less time, but actually takes more time due to its sheer inefficacy, is an approach which just tells you what to do, which steps to take to answer this type of problem or that type of problem. Thus, the whole course becomes less about developing solid problem-solving skills so that you can think creatively and formulate original solutions to challenging and unfamiliar mathematical problems, and more about just rote memorization and a futile attempt to try to categorize problems into different types, each with its own particular method of solution. So here's a very simple example. Solve by factorization the quadratic equation x squared plus 2x minus 15 equals 0. I'll just say that again. Solve by factorization the quadratic equation x squared plus 2x minus 15 equals 0. Step 1. Start by looking for two numbers which multiply together to give minus 15 and add together to give 2. Of course, these are minus 3 and 5 in this case. Step 2. Now use these numbers to write x minus 3 times x plus 5 equals 0. Step 3. Now reverse the sign of each of the numbers in the brackets and put them equal to x, giving x equals 3 and x equals minus 5. A perfectly good way of solving this quadratic equation, you might argue, except the important question of why this works is not even touched upon. It's simply follow these steps and you will get the answer. You don't need to understand why these steps work, what you're doing with these steps, why the correct answer is obtained. None of this is even bothered with. Many of those who have been instructed to follow this method cannot tell me when I ask them why x minus 3 times x plus 5 is the factorization of x squared plus 2x minus 15, other than because that's what my teacher told me to do. And then this is usually followed up quite comically with the question, why? Is it wrong? Many cannot tell me why a factorization is called a factorization. Many cannot tell me why factorization can be used as a suitable approach to solving quadratic equations. And many cannot tell me why x equals 3 and x equals minus 5 are solutions to this particular quadratic equation. And by the way, I'm talking about A-level maths students here. So now, someone who's learned to follow these steps will not be able to solve quadratic equations such as, say, 2x squared minus x minus 1 equals 0 using factorization simply because they have not understood how factorization works. They need to be told and thus remember another method for solving this type of quadratic equation by factorization. So we end up with this ridiculous situation where students are simply being told to learn umpteen different methods for solving quadratic equations rather than just being taught to understand. Naturally, the students get confused. They struggle to deal with types of quadratic equation that they don't recognize or can't categorize. And the most perverse thing about all of this is that the ones teaching in this way are teachers who should, I hope, understand mathematics. However, I do have serious doubts about this sometimes. So the upshot is that if you rely too much on classroom methods for learning mathematics, then in an alarming number of cases, you may be very unlikely to have the levels of success that you're capable of, or that you deserve, or that you want. And it's awful to think, isn't it, that even though you're doing what you think you should be doing, you think you're doing the right thing, you're being sabotaged. So I'm not saying that you should disregard what your teachers say. I'm not saying that you shouldn't pay attention in class and so on. What I am saying is that you will have to acknowledge the limitations that typical classroom approaches to teaching mathematics will place on you. Try to break free from these limiting teaching methods by choosing a different path, a path that leads to greater understanding. You can do this on your own, or with the help of someone who can advise you how to get there. Try to figure out the logic that underlies mathematics. Expose yourself to sufficiently challenging problems on a regular basis. Ask, why does this work? And genuinely seek an answer to that question. How will you know when you understand? You'll just know.